Hi everyone, welcome back to Code Cleanup. I'm Alena.
And I'm Alex. Between the two of us, over 20 years of front-end experience, or at least 20 years arguing about sorting algorithms.
This series is all about taking real code, something ugly, something slow, and make it shine. Today we'll keep refactoring our contact book app. If you haven't seen the previous episode, a hint should pop up somewhere on the screen.
This time, we are cleaning up a small innocent-looking function that sorts contacts by name or city.
And yes, it's a bubble sort, written by AI. You've been warned.
Here in the function, 2 nested loops, 2 lowercase comparisons, and manual swap.
It technically works, but it's slow and hard to read. Also, changing the original array can lead to strange bugs in React.
Before we touch the code, let's write tests. Tests protect the behavior while we change the implementation.
Exactly. We don't want to change the behavior by accident. So what do we test here?
We want to cover both sorting directions, ascending and descending, and both fields, name and city.
We have a simple test that checks an empty array. Let's write something more meaningful, sorting by name in alphabetic order.
Notice the lowercase Alice. The test makes sure sorting is case-insensitive, with lowercase before comparing, so Alice comes before Bob.
Next, the same, but from Z to A.
This confirms the sort direction flag flips the comparison logic. Simple, but crucial.
Now let's switch to sorting by city.
Same idea, we check that lowercase comparison works for cities too.
And the reverse version, just to be sure we are converting both directions.
If this fails, it means we flipped the comparator logic somewhere, and we'll catch it right away.
Let's see if it actually works.
Looks good, so now we have 5 solid tests, each proving one specific behavior for this function.
And when we refactor, we'll know immediately if we broke anything. Green tests mean we are safe to move forward.
So let's talk about what's wrong with bubble sort. It compares every pair repeatedly, even when the list is almost sorted. That's big O of n squared. The time grows quadratically. If we have 10 times more contacts, the processing time will be about 100 times longer.
Meanwhile, in modern JavaScript engine like V8, Array.sort uses Timsort. It mixes 2 classic algorithms to make sorting faster. It's smart enough to see when part of the array are already sorted and skip extra work.
So in practice, Array.sort is not only cleaner, it's way faster. Instead of comparing every item with every other item, it minimizes the number of passes and works roughly in big O of n log n time.
And we get that performance boost for free. No manual loops, no custom swapping, just one clear comparison function.
Great, so we can just replace the loops with contact sort?
Yes, with one important twist. Array.sort mutates the array. In React world, mutation props or state can cause sneaky bugs, so we will sort a copy.
With bubble sort, we decide swap or not on each pass. With Array.sort, we don't swap manually, we give a small comparison function that tells the engine which item comes first.
Exactly. Here's how JavaScript reads the result of our comparator. If it's negative, A comes before B. If it's 0, the order stays the same. If it's positive, A comes after B.
Negative means move A to the left, positive means move A to the right, and 0 means they're equal.
Let's run the tests to check if it still works.
All good, but the comparison logic is way too complicated with those nested ifs. Can we simplify that?
Indeed. Let's first move the equality check to the top, since we don't need to check sort direction if the fields are equal.
Done. And I see that if sort direction is descending, we just flip the value. So let's store the comparison result separately.
Got it. So if the sort direction is ascending, we can return this value as is. If the direction is descending, we need to flip it.
Just curious, can we avoid string comparison, sort direction, on each iteration and do it once?
We can encode the direction as a multiplier, even outside of the sorting function, to avoid checking it on each iteration.
Amazing, now it's native, optimized and readable.
Same logic, fewer lines, and tests will catch if anything breaks.
Let's run them. All green means we didn't change the behavior.
Okay, our sort works fine, but look at this comparison part. It's a bit old school.
Yeah, we are doing to lowercase, then manually checking greater than, less than, and strict equality. It's a lot of code just to compare two strings.
Exactly. There is a built-in method that does all of this and does it better. It's called localeCompare. It returns negative, 0 or positive, which is exactly what Array.sort expects.
That's way shorter, but what's the locale part? Does it actually care about languages?
Good question. Yes, it sorts strings in a way people in that language would expect. For example, in German, umlaut should come near A, not at the very end like in a pure Unicode order.
So let's pass English for now.
It's shorter, more readable, and correct for human-friendly sorting.
Checking tests. All green.
By the way, if you know anything about the performance characteristics of localeCompare or have experience using it in production, we'd love to hear from you in the comments below. We can add even more tests to make this function bulletproof. What else can we test?
First, we want to prove we don't change the original list. That matters in React because changing inputs in place can create surprising UI bugs.
So, we take a snapshot of this input, sort, and then assert the original is unchanged. We also make sure the function returned a different array.
If this passes, we know our sort works on a copy and leaves the original stable.
Next, we make empty strings behave predictably. In ascending order, an empty name should appear first, because when you compare it as a text, empty comes before any letter.
That expectation says, put the empty string first, then Alice, then Bob, still ignoring letter case.
Together, these tests logs the behavior we care about: non-mutating, clear handling of empty strings, and consistent case-insensitive order.
Before we move on, here is a challenge for you. Can you think of a test that our function doesn't cover yet? If you spot something, drop in the comments.
Let's see it in the app. We have buttons for sorting.
The default sorting is by name ascending. You can see lowercase and uppercase together, but the order is correct for names. That is because we compare in a case-insensitive way.
Now sort by name descending. Names flips the other way, and equal names keep the original order. That is stable sorting at work.
Switching to city ascending. City names are ordered as people expect in English. That is because we use locale-aware comparison.
And the city descending. Same rules, just the opposite direction. The original list stays untouched because we sort a copy.
Let's do a quick recap of what we learned today.
First, write tests before refactoring so behavior stays safe.
Second, replace a slow bubble sort with the built-in array sort and return negative, 0 or positive instead of swapping items by hand.
Third, keep React happy by sorting a copy, not the original array.
Fourth, use a local-aware, case-insensitive comparison so people see natural ordering.
If this was helpful, please like this video, it really helps.
And subscribe for the next episode of Code Cleanup. We'll keep turning messy code into clear, fast, and reliable code. See you next time!